Hello everyone, today we are going to learn this operational amplifier. Operational amplifier, we see this is the part of electronics and this operational amplifiers is denoted by op-amps. Short term is what we call op-amp. This also operational amplifier are the basic consistent building block of analog electronic circuits. It is designed to connect the input and the outputs. Also, this operational amplifier has several uses, like they are used in computers, multiplication. It is also called the operational amplifier because it performs the following mathematical operations such as addition, subtraction, multiplication, integration, and differentiation. So it is called the operational amplifier because it can perform the following arithmetics, as you can see. This is the circuit of operational amplifier, and this operational amplifier, it has the several components. This is the circuit of operational amplifier, op-amp. This is the part of inverting input, non-inverting. This is output. So it has only three basic component parts, which is inverting, non-inverting, and output. It is called inverting because this one it is connected to the negative terminal or polarity. This one it is called non-inverting because it is connected to a positive. Yeah, we have the several properties of operational amplifier. You have to note this because they are very important to know the properties of any operational amplifier. One, a very high open loop voltage gain. So this one, as we know, this voltage gain will mean the ratio of output and input. So we will learn later what is voltage gain. Also, extremely high input impedance. The meaning of impedance, we say this is the total resistance of a circuit. So this one input, because current cannot flow through this junction here to this region, so we have to establish a certain pathway that can take the input signal to output. That's why we call it has high input impedance. A very low output impedance, the opposite of this one. Also, you can read this because these are the basic three properties of operational amplifier. Now you have to note the following here because now you know the inverting input, non-inverting, and the voltage output. This one. Now, this one is we call a positive voltage supply. This is negative voltage supply. Now, if VO, this output will be only positive if VP, this is positive, this is negative. So this is voltage P, this is voltage N, this one. So VO will be positive when VP is greater than VN. Also, VO will be negative when Vn is greater than VR. So you can observe here. This is, I said this is positive, this is negative. So this is Vn negative and this is Vp. Also, we have open loop gain of operational amplifier. This year we are talking about the ratio of voltage output and the voltage input. If you take the ratio of this voltage output over voltage input, this side, it is what we call voltage gain. So we will derive this all this formula. Yeah. So don't worry, just move together with me. We have also transfer characteristics of operational amplifier. Transfer characteristics. As I said, if Vp is greater than Vn, it means it is positive. This why this curve lie in the positive. But if Vp is less than Vn, it means it is negative. So this, as you can see, this graph lie in the negative sides. Yes. Now let's check the what we call also feedback in operational amplifier. The meaning of feedback, it means taking the output signal into the input signals. That is what we call feedback operational amplifier. You take the the output signal into input signals. It is what we call feedback in operational amplifier. But we have the two main feedback in operational amplifier, where we have positive and negative feedback in operational amplifier. Now let's check what is negative and positive. When the signal at input and the output are outphase, not here, outphase, the feedback signal is said to be negative. So if the output and input signal are outphase, they are not the same, they are not occurring at maximum and minimum at once, it means what we call negative feedback. Also we have the positive. When the input and output signal are in phase, not this one, we said that feedback is called positive feedback of operational amplifier. Now let's check. This is the basic one, this is the main one. This is my target now, to teach you the operational amplifier circuit. We have 6 operational amplifiers circuits, and you have to know the derivation of each operational amplifier circuit. Let's start with this one. uh, inverting voltage amplifier. Inverting means connecting the that terminal into the negative side. As I show you this one, this is connected to the negative polarity. So this is the diagram of inverting operational amplifier, this one. Now you have to find the voltage in this one, voltage gain in inverting. Now let's consider we have V in, voltage input, voltage output. We have this non-inverting is F3, and also so this is VP VN. Now because we have the junction here, this I, it will be IF. You equate just I is equal to IF, but we know what is I from Ohm's law. This one I'm trying to show you, this one. I is equal to IF, but we know what is I is equal to V over R. We are talking about V over R. We are taking this voltage over this R. For I, this IF, it will be VO over RF. But we know also if there is potential difference here. So we will take V in minus Vn over Rin is equal to V in Vn, this one, Vn minus Vo over Rf, this one, this one, yeah. Also, what to note, since Vp is grounded, as you observe here, this Vp is grounded. So this is what we call in point N is virtual earthly. So if it is virtual earthly, it means Vp is equal to Vn and is equal to 0. This Vn, Vp is equal to 0 also. You can substitute. If Vp is equal to 0 and Vn is equal to 0, you can minimize from this equation. So you will obtain this formula. Vp is equal to Vn is equal to 0, this one. By simplifying, you will get Vn over Rn is equal to Vo, negative Vo over Rf. Now, if you reciprocate this one, no, if you arrange Vo over Vn, this one, voltage output over voltage input is called gain, and which is equal to negative Rf over Rin. Resistance at output over resistance of input. That is what we call gain. We have also non-inverting voltage amplifier. Non-inverting voltage amplifier, it means you connect the negative, the positive, this is positive polarity to this voltage, and Vn is now earthly grounded, this one, this part. Now we also consider I, this I is equal to IF. Current here is equal to this current raising here is equal to IF, this one. You can observe here this. But we know Vn is equal to 0. So we will take Vn minus Vn is equal to R1, which is equal to IF, also is equal to Vn minus Vo over Rf. Now compare here. if it is not here, if it, for the case of all non-inverting, Vp is equal to Vn and is equal to Vn. So if you arrange, you will obtain this one. So this is will be our voltage gain and the resistance gain. This is for non-inverting. Let's move for the case of summing operational amplifier. It means it comes from it is named by sum all current. We have I here, I2, I3. These all current are connected in inverting here. This inverting in negative polarity. So you will take I, this I is equal to IF. This I is equal to IF. But you know I1, I3, I4 you obtain here. Let's start. For the case of, so I1 plus I2 plus I3 is equal to I, which is equal to IF, this one. This I is equal to this one, is equal to this one, is equal, if you sum all this one, this current, this is equal to this I, which is equal to IF, this one. Now define each term. What is I1? You know I1 is equal to V1 minus Rn. V2, I2, this one. I3, this one. Arrange this one. But as I said, for the case of inverting, Vn is equal to Vp and is equal to 0. So where there is Vn, put 0. So you will obtain this formula, this one. Now arrange to obtain gain. If you arrange to obtain gain, it will be VO over Rf is equal to Vn V1 over R1 summation of this one. Now the summation of all here, V1 plus V2 plus V3, it is what we call voltage summing amplifier, this one. Yeah, so you just sum here, very simple. You can also check this equation and this question and solve it. We have operational amplifier as integrator and integrator. Now for the case of integrator, it is connected, the capacitor, this capacitor is connected to the Vn, this one, inverting, this is inverting plus this is inverting. So you can take also I is equal to IC, but you know what is IC from the concept of electrostatic. IC is equal to d theta d charge over dt, this one, but you know what is charge, CV. Now put here V in, you already know this one, this is V in minus Vn, this one, V in minus Vn over R1 is equal to C, because C is constant, then take this one. So you will obtain this value, this one. Now you can put the sign of integration, because C is constant, you take it out, then make VO the subject, this one. So you will obtain this formula for the case of operational amplifier as integrator. Now let's check as difference operational amplifier as differentiator. Differentiator is the opposite of integrator. As you can see here, for the case of integration, the capacitor is connected here, but for the case of differentiator, is connected this one. For the case of input, now compare I is equal to IR. This one, I is equal to IR, but we know IR because it is inverting. Now you can substitute here to obtain this one. Yeah. So this is the general formula for the case of operational amplifier as an differentiator, this one. For the case of all inverting, Vp is equal to Vn is equal to 0. For the case of inversion, this one. The last one is operational amplifier as subtractor. Note this one. For the case of subtractor, it is connected to the inverting and non-inverting. So you will take I1, this is I1 is equal to I3, and I2 is equal to I4, this one, I4, compare this one, I1 is equal to this one is equal to this one, but you can compare to obtain the several value. The last part for today is we are talking about operation amplifier as a comparator. Comparator, we are comparing this one, R1, the fraction of R1 over R2, the fraction of R4 over R3 to obtain this one. This is operational amplifier as a comparator. Thank you very much guys for following me. Don't forget to subscribe, like, comment, and share.